If you're prepping for the AWS Certified Solutions Architect exam, you know Aurora is a big deal. You absolutely have to know it. But what really makes it tick? Why is it so different? Well, let's jump right in and pull back the curtain on the cloud-native database that honestly changed everything. Here's our game plan. First, we'll look at why the old way of doing databases just didn't work in the cloud. Then, we'll see the genius in Aurora's new architecture. After that, we'll dive into how it stays alive during failures, what that means for crazy performance, and finally, and this is key for any architect, how to make sure you're not overspending. Okay, so to really get why Aurora is so special, you first have to understand the problem it was built to solve. You see, traditional databases work great when you had one big server in a closet. But the cloud, it's a totally different world. Distributed, messy, and things are failing all the time. The old designs just couldn't keep up. And that really gets to the heart of it, right? Why couldn't we just use what we already had? What was the one big thing, the fundamental bottleneck that was holding everything back? This right here, this diagram shows the problem perfectly. In a standard high availability setup, like with MySQL, when your app does one simple write, it sets off this crazy chain reaction of network traffic. You're writing logs, then data, then a double write, just in case, and then you have to do it all over again on the backup server. It's just so chatty. And here's the kicker. All of that chatter, that I/O amplification, meant the bottleneck wasn't your CPU or your storage anymore. It was the network itself. The network just couldn't handle the traffic. The cloud needed a database that knew how to be quiet. And that leads us to Aurora's solution. And it's not just a small fix, it's a complete teardown and redesign of what a database can be. Now, this is the core idea. If you're studying for the exam, burn this phrase into your memory. The log is the database. What does that mean? It means Aurora just stopped sending big, clunky data pages across the network. The only thing it sends is a tiny stream of instructions, these little redo log records. The smart storage layer then figures out how to build the actual data pages on its own, in the background. So how does it actually work? This slide shows it all. Aurora completely separates the brains, that's your database instances, from the muscle, a shared storage service that's spread across multiple availability zones. They're two different things that talk to each other in a super efficient way. Now, remember that chaotic mess of a diagram we saw before? Compare it to this. It's beautiful, right? It's just one clean, simple stream of log records going to the storage service. That's it. All that network traffic jam, gone. And the results are just mind-blowing. The numbers speak for themselves. By cutting down the I/O per transaction by almost 8 times, Aurora can handle 35 times more transactions than a similar MySQL setup. That's not just a little better, that's a total game changer. Okay, so it's crazy fast, but can it take a punch? In the cloud, things are always failing. How does Aurora deliver the kind of reliability we need? This is another huge topic for the Solutions Architect exam. It all starts with this number, 6. Aurora doesn't make 2 or 3 copies of your data. It makes 6. And it manages those 6 copies, which are spread out over 3 different availability zones, using this really clever system called a quorum. Think of it like voting. For a write to be considered done, 4 out of the 6 copies have to raise their hand and say, yep, got it. For a read, it only needs 3 out of 6 to agree. This 4 of 6 for writes, 3 of 6 for reads is the secret to its toughness. So for your exam, you'll absolutely have to remember these points. Because of that write quorum, Aurora can lose an entire availability zone and just keep taking writes. It doesn't even flinch. It could even lose an AZ plus another server, and you still won't lose any data. On top of that, the storage itself is self-healing. It's built from the ground up to survive pretty much anything the cloud can throw at it. Now, when you combine that super efficient architecture with extreme reliability, you get something amazing. Incredible performance. Let's look at some real numbers. I mean, come on, look at this chart. It's not even a fair fight. On the exact same hardware, MySQL is chugging along at about 15,000 writes per second. Aurora, over 120,000. That is what happens when you get the network out of the way. And check this out, replica lag. This is huge. With MySQL, as your workload gets heavier, your read replicas fall further and further behind. We're talking minutes behind. They become basically useless. But with Aurora, because the replicas are just listening to that same lightweight log stream, the lag stays in the single-digit milliseconds. Your replicas are always fresh. And this isn't just theory. This is a real customer. They switched their web app to Aurora, and bam, Response times dropped from 15 milliseconds down to 5.5, a 3 times improvement just from changing the database. That's the real-world impact we're talking about. Okay, as a solutions architect, you know that speed and reliability are only 2 parts of the triangle. The third is cost. So you need to know how to design cost-effective solutions with Aurora. Let's break down your main choices. Your first big decision is between standard and I/O optimized. Think of it this way. Standard is pay-as-you-go, where you're charged for every single I/O operation. It's great for most apps, but if your application is a real I/O monster, I/O optimized is like an all-you-can-eat buffet. You pay a bit more for compute and storage, but all your I/Os are free. This can save you up to 40% and makes your bills super predictable. Next up, provisioned or serverless. Provisioned is the classic model. You pick a server size and it runs 24/7. It's perfect for your steady, predictable workloads. Serverless, though, is magic. It's for those unpredictable workloads. It scales up when there's traffic, and when there's nothing happening, it scales all the way down to 0 so you're not paying for idle time. Perfect for dev test or apps that get spiky traffic. And speaking of those steady, provisioned workloads, please don't forget this number, 66%. That's how much you can save on your compute costs by committing to a 3-year reserved instance. As an architect, knowing how to pull these levers is how you build truly cost-optimized systems. All right, let's wrap it all up. Here's your cheat sheet for the exam. Number 1, Aurora decouples compute from storage. 2, its log is the database philosophy slashes network I/O. 3, it uses 6-way replication and a 4 of 6 quorum for insane durability. 4, this all leads to massive throughput and super low replica lag. And 5, you have flexible pricing models to control your costs. Got it? Which leaves us with one final thought to chew on. When you look at how Aurora completely rethought the relationship between compute, storage, and the network, you have to ask, is it just a really good database? Or did it actually write the blueprint for how all databases have to be built in the cloud era? Something to think about.